Hey everybody, let's build a version of Tetris using Scala Native and the Scala Native GTK bindings. This is going to be a complete version of Tetris, more or less. There's a few things that are probably missing, but it's complete enough to play, and there's a lot of opportunity from that point to take the project how you want. The source code is going to be down below for everything that we do. We're going to start from a basic Scala GTK example and work our way up to Tetris, and hopefully I can get some time, some actual skill playing Tetris, and maybe a eyepiece here to really seal out the demo here. Ah, yeah, there we go. Before we get to Tetris, we're going to just do a basic Scala Native GTK example. Setting that up, getting it built, and running it in Nix. We're specifically going to be using Nix Flakes to do this. I'm on NixOS here, and I have Nix Flakes enabled, but you should be able to follow along with other Nix supported systems that also have Flakes enabled that can use these GTK libraries that Nix provides. We're going to look at this example real quick. This is the example from the Scala Native GTK bindings project. This example sets up a window, adds a button, and has that button print to the console every time we click the button. And we'll go ahead and just run that now. See the button, press the button, and note, we printed to the console. Very exciting, but it's a starting place for our Scala Native development under Nix. The source code to both these applications is going to be down below, both the repository for this basic example, which is a good one to fork if you want to try a different Scala Native project that uses GTK, as well as the project for the Tetris, which I'm going to continue to refine, but this other one I'll probably keep as a good template application for people to reference. The components we're going to use to put this together are, of course, the GTK4 bindings for Scala 3 native by side effect here, and the SPT derivation Nix library for building SPT-based Scala projects with Nix. Both of these have introductions on how to use them. We're going to be going through the Nix Flakes usage of SPT derivation. And for GTK4 bindings for Scala 3 native, the installation instructions mention macOS and Debian. We're going to be using Nix, like I mentioned, for setting up our installation, so these don't apply. However, we are going to be using package config as the mechanism to get those flags into SBT. I want to first go over how to bootstrap a basic Scala Native project to use Nix Flakes for a development environment. Here is the Scala Native seed project. It's a hello world. This is generated with SPT new Scala Native. There's not much to this. It's just a main of hello world. It does import the Scala Native plugin, and it has the default build.spt. We're going to start here, bootstrap this into a Nix Flake development environment. Then I'm going to show the GTK project and the changes that were necessary there. This is useful though if you're just working with a Scala Native basic project. The flake we're going to start with is this one here. This prelude is just the description and our dependencies for this flakes. We are dependent on Nix packages, the SPT derivation library, and this Nix systems library as well, which gives us a bunch of different default systems supported by Nix. Our outputs for this flake depend on self. That's this project's source code, nicely cleaned up properly. Nix packages, SPT, and systems. Then for each system that we support, we're going to build this package here using make SPT derivation. Since we're bootstrapping the environment, we don't know what our depth SHA is yet. So we're going to leave this blank. We'll have the system tell us in a bit. This is tofu, trust on first use. Our build phase is just SBT compile. That's the default recommended by default for the SBT derivation. We're going to change that to native link. We're going to start there, but we're going to change this later to make it easier to distribute. Our native build inputs include Clang and a few other dependencies needed by the build environment. With this minimal Nix flake, the next thing we're going to do is in a new shell here, I'm going to do Nix develop. This is going to attempt to set up the development environment, but it's going to fail because we haven't defined our deps SHA. And you can see that warning here. I'm going to wait for a bit for it to determine the deps SHA. It will tell us that and fail. There we go. So we're going to take this deps SHA, copy it, go back to our flake here, and paste it in here. We have to update this SHA anytime we update our dependencies, and it's important to keep that in mind. With that change, we run Nix develop again, and we find that we're in our Nix development environment. We can start up SBT. And run the executable. You can see quite a number of errors printed out according to SBT. These are actually warnings. Don't worry about them yet. We'll resolve these shortly. These are all related to additional settings Nix adds by default to its projects that compile using Clang that don't apply when we're using the default settings for SBT Scala Native. They can be safely ignored. And you can see here, compiled and ran, and we have our hello world as expected. Now that we have this compiling and running in our Nix development environment, let's try packaging it as a Nix package. And if I was to just try the native link here, it'll produce the native executable at target Scala 3.3.1 Scala native C project out. And I would think I'd be able to just take that and create an install phase that looks like this. We make our bin directory and we copy that to our output bin directory. Unfortunately, this isn't going to work. And I'm going to show you what this looks like when we try. The reason this isn't going to work is twofold. One is that it's probably not a good idea to have this reference to Scala 3.3.1, the specific version in that flake. That version is set by the build.sbt file, and that's not known by the Nix flake. So that's an issue. It's more of a resilience issue than a problem. The other is this, is it's going to attempt to find this file, but given how this SBT project is set up, and I'll go ahead and pull that up, it doesn't have a stable name for that output. It's going to depend with this format on what the name of this directory is. And when we attempt to do a Nix package of it, what's going to happen is it's going to generate some folder name, some temporary folder name, and this executable is going to have whatever that temporary folder names as its name. So how do we resolve that? One, we do the same thing to resolve both, which we just create a new task that produces the executable into a stable location with a fixed name. Back in our build.sbt, I'm going to define the task as follows. It's going to be called stage. I prefer the name stage. You can use something that's suitable for you. What it's going to do is going to get a path to the native link compile result. We're going to have a target file named Scala Native Hello World. You can make this a task setting if you wanted. We're going to copy from that native link result to the target file and return that target file for convenience. We're going to reload my SBT. I do reload instead of quit and then come back to it because it actually retains the client connections and it's a bit faster. Okay, so we've now reloaded our SBT and I want to execute that stage task that I just created. And now you can see the result from that, which is stable path from target Scala Native Hello World. With that path, we're going to go back to our flake.nix. We're going to change this install phase and this build phase to reflect our new stage and for our target and replace it with this much simpler command, which doesn't include that Scala 3.3.1. Now we only have to keep this executable name, which is probably a bit more stable than the Scala version that we're targeting. Okay, now that we have this done, I am going to exit out of SBT here, and I'm going to exit out of our Nix development environment here. I'm going to go ahead and add this to our Git repository. With this setup, I should be able to do Nix shell, which is going to create a shell with a profile that includes this current project. Wait for it to compile. It's going to compile the full thing from scratch. Nice reproducible deterministic compile. And we're done. And you'll note now in our path, we have our Scala native hello world, which prints out hello world. Excellent. So now we've done a minimal setup for Scala native using Nix Flake, both distribution and development. With that working, we're going to ramp up the complexity a bit and get our GTK example up and running. This is the flake.nix we're going to be working with. You'll notice that this is pretty much the same at the beginning. And then down here we get to some differences. One is, of course, I've changed the name to GTK example because I wanted to. Same with our install phase. Our build inputs now include GTK4, which means, since we changed our build inputs, this deps SHA-256 has been changed. Other than that, this flake.nix is the same. When we get to our build.sbt, there's going to be some changes there too. Note, we still have our stage task, and we're still doing our stage copy as usual. This time, however, I've placed everything in a lazy val root at the top instead of the top level of the build.sbt. I prefer this style. I think it's a bit more resilient as you build your project out, and especially when you get to multiple project SBT builds. There have been some additions though. One is we've changed the mode to release fast. That gives us just a wee bit of compilation optimizations when we pass it off to Clang, which does resolve those warnings that we were seeing about Fortify that Nix adds. In addition, we need our compile options and linking options for GTK4. And for this, we're going to delegate to package config. And specifically, we're going to tell package config we want the GTK4 package, and we want the C flags and libs. Similarly, that gives us the native library dependencies we need, but we need our Scala native library dependencies, and that's what we've added here. And this is just the standard library dependency for the GTK4 bindings. This package config function I pulled directly from that GTK bindings. It's fairly straightforward. It just starts the package config process with the arguments we provide. The results are split on space to get it into in a list instead of just a single string of arguments that we need for our compile options and linking options down there. With that set up, we can now go back into our Nix development environment, and we can see that package config does indeed have the configuration we need for GTK4. And if we start up SBT here, we can hit run, wait a while, and our example has started. Wonderful. We've also set this up for distribution, so let's go ahead and try that. And again, that's Nix shell, and we should have our Scala GTK example here. That's excellent. I started that Nix shell directly from the current project directory, but if we were on a different system which didn't even have this checked out, we can do this as well. First, I'm going to figure out the SHA here, just to make it a stable reference for people consuming this. Copy it. I'm going to go ahead and create a new shell on my system. So this has no association with any environment of the previous one. And I'm going to do Nix shell GitHub followed by that SHA. Broken down, this is, we're saying we're going to reference from the source GitHub, which Nix knows how to reference repositories there. We're going to reference the repository Scala GTK example and the specific SHA here. Now when I run this, it's going to check that GitHub repository, check that flake.nix, build everything, and get it ready to go. Now, I've already done this in the previous one on this system, so it just memoized those results and immediately brought us there. If we were on another system, this might take a bit longer, and indeed we can see our example is up and running. That's all we're going to do for this video. Next one, we're going to get straight into Tetris and set up the game loop, the main loop there in GTK. Until then, I'll see you all later.